Our bagel is ready. Hey guys, just we're going to skip to 7.4 Pythagorean Theorem and its converse. We will go back to 7.3. In fact, that will be your homework for one day this week. I will let you know what day that is. Okay. So you'll be able to, for this lesson, apply the Pythagorean Theorem and its converse and classify triangles by sides and solve problems. Okay. So aligned to this lesson are IXL units Q2 and Q3. After you finish completing these notes, you are going to do Q3 immediately, okay? And then Q2 will either be homework or I will actually have it posted on tomorrow's agenda, or rather today's agenda once you come into the classroom, okay? So the converse of the Pythagorean theorem. So if you recall, a conditional statement is an if-then statement, where if is the hypothesis and then is the conclusion. For example, if a triangle has 190-degree angle, it is a right triangle. That would be a conditional statement. The converse of that swaps the hypothesis and the conclusion. So if a triangle is a right triangle, then it has one 90-degree angle. All I did was switch the order of the hypothesis and the conclusion. That would be the converse. So in this case, for the Pythagorean theorem, it states if triangle ABC is a right triangle with hypotenuse C, then A squared plus B squared equals C squared. The converse of the Pythagorean theorem is, in the case of triangle ABC with longest side C, if A squared plus B squared equals C squared, then triangle ABC is a right triangle. Why is this important? Well, say you are given 3 side lengths in a triangle and you're being asked to prove that the triangle is a right triangle. How are you going to prove it? Well, for example, in this case here. Now, I ended up drawing this 90-degree angle in after I tested the converse of the Pythagorean theorem. So all I had initially were these side lengths here, 12, 16, and 20. Knowing that C is the longest side is super important. So I labeled the side that was 20 units as side C. It's also directly opposite angle C. I named this side, the middle side or the mid-sized side, side B, which is directly opposite angle B. And then I named A, side A, which is opposite, and the smaller side, which is opposite angle A. So I have my A, my B, and my C, C always being my longest side. So then I took the Pythagorean theorem and I plugged in A, B, and C. A squared is 144, B squared is 256, and C squared is 400. 144 plus 256 is 400, 20 squared is 400. Therefore, these numbers make the Pythagorean theorem true. Therefore, yes, triangle ABC is a right triangle because A squared plus B squared equals C squared. Therefore, C is a 90-degree angle. Okay, and so that was my explanation. Now, what if I was trying to determine whether a triangle is acute, right, or obtuse just by using its side lengths? Okay, so here it states given triangle ABC with longest side C. You're going to see a lot of scribble, scrabble, and stuff that I did. I'm going to explain everything, okay? So we can determine whether triangles are acute, right, or obtuse based on their side lengths. Here's how to do that. Now we know that if we have a triangle with a right angle marking in it, its side lengths are going to make the Pythagorean theorem true. But say we're not given this, like in the example here, and we're just given some numbers here, what we would do is take the 2 shorter sides, square them, add them up, and make them equal to the longest side. If that equation holds true, then we know that we're dealing with a right triangle. But what if it doesn't? So for example, here I have this triangle, ABC, and one side, side A, or the side that's opposite angle A, side A is 6, B is 8, and C is 9. If I take the two shorter sides, add them up, rather square them, and then add them up, and that value is greater than the longest side squared, then the triangle is acute. Again, if I take this, and that's what I did here, if I take a squared plus b squared, and it's not equal to c squared, then it's either going to be greater than c squared or less than c squared. If it's greater than c squared, it's acute. If it's less than c squared, then it is obtuse. Okay? Let's actually do the work for that. So again, I made this 6 units in length, that 8 units in length, and that 9 units in length. So 6 squared plus 64, or plus 6 squared is 36, plus 8 squared, which is 64, is equal to 100. Okay? 100 is not equal to 9 squared, okay, because 9 squared is 81, but 100 is greater than 81, which is 9 squared, okay? And so if we took these two sides, we added them up, or squared them, then we're getting at 100, which is greater than this side c, the longest side squared. And so if a squared plus b squared is greater than c squared, then we have an acute triangle. Another way of saying that is if your longest side squared is less than the sum of your two shorter sides squared, then you have an acute triangle. Let's talk about obtuse triangles. So it's basically the opposite. So if you take your two shorter sides, you add them up, square them, you square them and then add them up, and they're less than the longest side squared, then you have an obtuse triangle. For example, I made A 3 units in length, I made side B 5 units in length, and then side C 6 units in length. So I just made up these, I gave myself some side lengths to work with, just to test this theory. So we have 3 squared plus 5 squared, which is 9, plus 25, which is 34. Then the longest side is 6, and 6 squared is 36. So a squared plus b squared is less than c squared. And if a squared plus b squared is less than c squared, then we're dealing with an obtuse angle here. Okay? And so that's how we can tell if we're dealing with obtuse, acute, or right triangles. For unit Q3 on IXL, you're going to do exactly this. You're going to take the side lengths they give you, you're going to square A, square B, add them up, and then see if the sum you get is equal to, greater than, or less than c squared, okay, which is always the longest side. What you're going to do is the try it out. Okay. So you'll be doing the try it out. I did the second one for us, and I'll give you a quick explanation, but you are responsible for number 1 and number 3. All of these notes will be checked on Tuesday in class while you're doing the do now or while you're doing your independent practice. So you're going to state if each triangle is right, acute, or obtuse. Justify your response with algebraic support. So I labeled my sides A, B, C, knowing that C is the longest side. I label that one C. A, I always give the shortest side A, and then the mid size B. So C is always the longest side, all right? Make it a point to write that. So 9 squared plus 14 squared is equal to 15 squared. I just plugged it into the Pythagorean Theorem. That's the way I do it, okay? But you can just do it differently. You do it however you wish in terms of if you just wanted to do 9 squared plus 14 squared, figure that out, and then determine what c squared is. But I plug it into the Pythagorean Theorem. All right, so it's going to give me 81 plus 196, which is equal to 277. Well, 277 is not 15 squared. So what I get when I add these and what I get when I when I square c is two different values, okay? So they're not equal to each other. And in fact, a squared plus b squared is greater than c squared, which means we have an acute triangle, because if a squared plus b squared is greater than c squared, then the triangle is acute. Do the other two on your own. Ask me questions if you have any. Then move on to Q3 once you're done.